Hello grade 12s, welcome back to the channel, Science Therapy, hosted by the one and only science therapist. And in today's lesson, we are going to be looking at definitions you should know for momentum and impulse. So without any further ado, let's go. The first definition we have is momentum, and we say momentum is the product of the object's mass and its velocity. Then we have impulse, and we say impulse is the product of the net force acting on an object and the time the net force acts on the object. We know about the principle of conservation of linear momentum, but how do we then define it? We say the principle of conservation of linear momentum states that in an isolated system the total linear momentum is conserved or remains constant. Before your whole world comes crumbling down, let us understand what is meant by the term isolated system. An isolated system is a system for which the net external force is equal to zero. Another definition that is not as much frequent in your past exam papers but is crucial to know is the definitions for the Newton's second law in terms of momentum, which states that the net force acting on an object is equal to the rate of change in momentum of the object in the direction of the net force. We also ought to understand the difference between an elastic collision and inelastic collision. To start off with the elastic collision, we say this is the collision where the total kinetic energy is conserved. That is to say that no kinetic energy is lost during an elastic collision. An inelastic collision, however, is a collision where there is loss of kinetic energy. But it is important to note that this energy is not completely destroyed but converted to other forms of energies, like sound energy and heat energy during the collision. The fact that in both these collisions, whether elastic or inelastic, the total linear momentum remains constant or is conserved.